welcome to my channel Suriyas Academy. If you are new to my channel, then hit the subscribe button and press the bell icon for more interesting videos. We had been discussing the number system conversion types, number system conversion series. In today's video, we are going to discuss about the hexadecimal to binary conversion. In the hexadecimal to binary conversion, we can use two types of methods. The first method is converting the hexadecimal to decimal, and from the decimal converting it to the binary conversion. This is the first method. And the second method consists of directly substituting we all know that the hexadecimal can be represented by a 4-digit binary value. By directly substituting the 4-digit binary value, we can convert it into the binary value. Then for integer type and with a fractional value, how it can be substituted, the examples have been discussed here. Now we first move on to the first method. Consider the example A5. We all knew that the hexadecimal consists of digits from 0 to 15, and from 10 to 15 it is represented by alphabets A to F. And each hexadecimal is represented by a 4-digit binary value. This is listed in the table here. So now when we want to convert this number A5, we want to convert it into the decimal system. For converting to decimal system, the idea here is we have to add weightages starting from the right to the left. Since we are having an integer value, the values can be substituted from the right to the left. So for 5, 16 power 0. For A, which is represented as 10, the value of A is 10. 60, for 10 it is substituted as 16 power 1, the weightage is added. Now after weightage is added, we have to multiply with the concerned particular digit and the sum of the products has to be found. So 10 into 16 power 1 plus 5 into 16 power 0, which gives 160 plus 5, which gives 165 to the base of 10. Now we have arrived the decimal value. We want to convert it into the binary value. For converting to binary, the decimal number has to be continuously divided by 2 till it reaches a minimum value, and the reminders has to be noted, and finally the values has to be written from the bottom to the top. Consider 165 divided by 2, which gives 82, remainder 1. Again dividing by 2. 82 when divided by 2. Since it is a small number, I am directly representing the answers. You can check it out. 82 when divided by 2, which gives 41, remainder 0. 41 when divided by 2, which gives 20, remainder 1. 20 when divided by 2, which gives 10, and then remainder 0. 10 when divided by 2, which gives 5, remainder 0. Again 5 when divided by 2, 2 2s are 4, remainder 1. Again 2 when divided by 2, 1 2s are 2, so 1 is represented here and the remainder 0 is represented here. Since we had already discussed about so many times these type of conversions in the previous videos, I am directly representing the answers. So now the answer can be written as, starting from the bottom to the top, 1 0 1 0 0 1 0 1. So 1 0 1 0 0 1 0 1 to the base of 2. This is the binary value. Hexadecimal consists of base 16 and binary value consists of base 2, which consists of zeros and ones. So we are converting to decimal, and from decimal we are converting to binary. Now consider the second method. I am taking the same example A5. A5. For A, it is represented as 10, and 5 it is as it is 5. So for A, consider the table. Each hexa number is having a 4-digit binary value. The table is represented here. Suppose if you can't able to remember the table, a short trick is consider a example 6. How it can be converted to 4 binary digit? 6 when divided by 2, 2 3s are 6, remainder 0. Again 3 when divided by 2, 1 2s are 2, remainder 1. So when writing, we arrive as 1 1 0 the value. Since the hexadecimal is always represented by 4 binary digits, a 0 can be added here. So 6 can be represented as 0 1 1 0, which is represented here. Likewise, for each values we can able to calculate here. This is the methodology followed here for converting the hexa value into a 4-digit binary value. This is the methodology followed here. So for 5, from the table we can directly represent 0 1 0 1. For A 10, it is represented as 1 0 1 0. So when writing 1 0 1 0 0 1 0 1 to the base of 2, the answer is same here, 1 0 1 0 0 1 0 1. So the same answer we are getting here. This method, when considered, the first method, when we have a very large hexadecimal value, say for example, it consists of more than 5 or 6 digits hexadecimal value. So typically the decimal value will also be large. When we are having a large decimal number, when converting to binary, when we have to go on for so many iterations, we have to go on dividing and it will be very lengthy. So this process will be a tedious process when we have a very large number. For small numbers, we can use this methodology. For large type of numbers, the second method is the best method to convert from hexadecimal to binary. Now the integer values is represented. Again, consider an example with the fractional values. Here A13F 0.2D A6. Again the simple substitution methodology. For A it is represented, A is represented as 10, its value, 1 as it is, 3 as it is, F 15. Again D 13, A represented as 10. Here it is written the concerned digits 10, 1, 3, 15, 2, 13, 10, 6. The idea here is we have to write this is the concerned hexadecimal digit. For the concerned hexadecimal digit, we have to write the 4-digit binary value. We can either directly take it from the table and write. Consider for 10, 1 0 1 0. For 1, 0 0 0 1. For 3, 0 0 1 1. For 15, 1 1 1 1. And again after fraction also we have to represent as it is only. For 2 0 0 1 0, here the decimal point can be represented. For 13 1 1 0 1, for 10 1 0 1 0, and for 6 0 1 1 0. Again when combining all the answer we can write here as 1 0 1 0 0 0 0 1 0 0 1 1 1 1 1 1 dot. Again writing all those answers 0 0 1 0 1 1 0 1 1 0 1 0 and 0 1 1 0 to the base of 2. So likewise we can able to substitute and find the binary value directly. When you can't able to remember the table or if you find it difficult, then we can convert using the simple divided by 2 continuously until it reaches a minimum value, and then write it from the bottom to the top. When you have a 2-digit or a 3-digit value, add zeros before and change it into a 4-digit value. This is the simplest methodology we can follow here when you can't able to remember the table. So today we had discussed about hexadecimal to binary, in which we have 2 types of methods. In the first method, we are converting from the hexadecimal to decimal value, and from decimal we are converting to binary value by continuously dividing by 2 till it reaches a minimum and the values are written from the bottom to the top. This is the first method here. And in the second method, it can also be known as a substitution, direct substitution method. Here, in which for your reference a table has been given here, this table can be find out by take an example 6, we can continuously divide the number by 2 and the values, the reminders are noted and the values are, final values can be noted from the bottom to the top. When you have less than, when you have 2 digits or 3 digits, by adding by adding zeros here before, we can change it into a 4-digit binary value, and hence the hexadecimal value, the 4-digit binary value can be found here. Using this methodology, we can directly substitute here. Here for integer, we can represent by 4 binary digits, and you can write here. And for the fractional values, again a decimal point can be added. The same methodology for the integer value as well as the fractional value. Each hexadecimal digit is represented by a 4-digit binary value. Again the answers are noted here. For integer it is integer, and after integer the fractional part with the followed by decimal point. Again the values are noted here. Hope you can understand clearly now the idea. Okay, that's all for today's video. Keep supporting Sai Suriyas Academy. In my previous videos, in the number system conversion, other types of conversions has been taken. So if you want to check my number system conversion playlist. Okay, thank you.